Hey everyone, welcome back to another video. Today we are going to be defining an equation for velocity as well as analyzing what the velocity is in a position versus time graph. Okay, so here I have a nice little video of three balls rolling at some different velocities, and we want to determine which one is going to cross the finish line. All right, so here we have our balls rolling and we want to determine which one is going to cross the finish line. Today I'm actually only going to be focusing only on the white ball. Okay, and then hopefully later on you'll be able to determine which one is going to be able to cross. All right, so without further ado, let's kind of get started. And to start it off, let's talk about the Walking Man Lab. Okay, part two. So, Walking Man Lab, part two, number 6, we could determine, it asks for you to put it at a position of 0 and a velocity at 2. Okay, so I'm going to set this guy's velocity at 2, and all I'm going to do is I'm going to take some data points as I go along. Okay, so here stops at 1 second, and it's close to 2. Okay, so I'm going to write that 2 down. Let's kind of keep going. And oh, too slow. All right, 2 seconds go by, and then it has a position of 4 meters. Okay, and let's kind of keep going. 3 seconds go by, and he has a position of 6 meters. All right, and we can kind of see that there is a pattern developing. And 4 seconds go by, and then we are at 8 meters. And then, assuming the pattern kind of continues, 5 seconds go by, and he's at 10 meters. All right, and so we could kind of see that right now, that my position only increases by 2 after each second goes by. Okay, and that would kind of make sense because we just said that velocity is just going to be some distance over time. Okay, so I'm going to maximize this so that way you guys can see. So in this case, let's define what velocity is. My velocity is going to be equal to whatever distance an object travels. Distance, okay, divided by the time it takes, or the time, all right? And we can see that in smaller intervals as well. Okay, so in this case, we started at 0 and we started at 10, or we ended at 10, okay? And we started at 0, okay? And I'm going to divide that by my time. Sorry, if I put t right there, it's time. Okay, so ended at 5 seconds and started at 0. So 10 divided by 5 is equal to 2 meters per second. Okay, so we could determine that. And now we can also see that as each second goes by, my position increases by 2 meters, which makes sense because that is what a speed is. Okay, so now what I would like to do is, with that logic, what would happen, okay, since we defined what velocity is, and we can do this for any interval per second, right? So let's say I wanted to do what is the velocity from 2 to 3 seconds, right? So in this case, my velocity is going to be equal to where I ended, which is 6, minus where I started, which is 4, okay? And I'm going to divide that by 3 at 3 seconds minus 2. Okay, so in that case, 6 minus 4 is equal to 2. And then 3 minus 2 is equal to 1. So therefore, I'm still going to get my 2 meters per second. Okay, so in that case, we defined what my velocity is, right? Using some math. And so what I'm going to do now is, what happens if I don't have just this walking man, and and if I want to determine how long it's going to take something? So let's say I have only this data table and I wanted to determine what the velocity is going to be. So what I'm going to do is let me erase this really quick. And I'm going to go to this simulation right here. Okay. So I'm going to scroll down and I already pre-selected some data. So let's say I have data in this right here. Okay. So here I have 0 seconds and I start off at 0 meters. 1 second goes by, I'm at 4. 2 seconds go by is 8. 3 seconds go by is 12. 4 seconds go by is 16. So based off of this data, can you tell me what that velocity is going to be? My velocity is going to be. In this case, I could see that as each second goes by, I'm increasing each data slot by 4, right? So I'm increasing each data slot by 4, which would mean that if I also did its total distance, so because velocity is equal to my distance, centimeters, because it's in centimeters, by the way, and divided by 0 centimeters of where it initially started, divided by 4 seconds minus 0, I'm going to get 4 centimeters per second, right? And I mean, we didn't really have to do this mathematically. We could have just saw that it was increasing by 4 each time. I just wanted to show you that these two are pretty much equal. All right, so we could see that this velocity equation is going to kind of check out. So I know that it has a velocity of 4 centimeters per second. All right, so now, what about this? What happens, okay, if I want to view it from a graph? Okay, so right now, let me configure my vertical axis, and I'm going to say that is going to be a distance. Okay, and then my horizontal, I'm going to give it a time. And so therefore, I'm going to get these nice little data plots. Okay, so once again, from pretty much your math classes, 1 second right here is going to be equal to 4 centimeters. 2 seconds is going to be equal to 8, because all it's doing is just plotting these numbers into this graph. All right, now I'm going to show you something kind of cool, and it is going to make this no, not a lab, but this assignment a little bit easier. Okay, so let's say I want to determine the velocity just by looking at this graph. What could I do? Well, what I want to do is I want to click on this button right here, this little gear, and I want to go to where it says curve fits. If I select linear, okay, it gives me a nice straight line. Okay, so, and it tells me, okay, so x is going to be equal to at plus b. It's just a line equation. Don't be afraid by that. What I would like to highlight is this, or this value right here, a. First of all, what is a? Well, a, in this case, according to your math classes, is my slope. Okay? It is my slope. Okay, and what is my slope? The number for my slope? I could see that it's 4 centimeters per second. The same thing as what I have calculated up here. So is this a coincidence? It's actually not, okay? And in fact, once again, slope, if you would like to remember as a nice refresher, it is going to be your rise. Oh wait, actually, let me erase this really quick. Your slope of any line is going to be your rise over your run, right? Divided by your run, which makes sense. So for a position versus time graph, my slope is just, or my velocity is just going to be the slope of this line. Okay, and that's going to be very useful information when dealing with this problem that I'm about to tell you. All right, so what I'm going to do is I'm actually going to pause this video really quick. I'm going to erase this data and I'm going to get some stuff set up. Okay, so right now what I did was I kind of got rid of all of the data and we're going to kind of start fresh. Okay, so right now I want to determine how long it's going to take this white ball to reach the finish line. All right, so let's kind of go over a couple of things first before we even begin. First of all, I clicked on this toolbar, and I clicked on this ruler looking thing, and it gives me and orients it to a point where I could determine these distances. Okay, and I'm gonna move it for this ball at least to where my start is going to be the beginning of the ball, because once it passes this finish line, that's when my time stops. Okay, so in this case, I could see that my ball needs to travel a total of 64 centimeters according to this line. So right now, I'm going to write ball needs to travel 64 centimeters. Okay, because this video doesn't go all the way through to actually finish line. All right. All right, so 64 centimeters to the finish line. Let's kind of go into it. So right now, I need to collect some data in order to determine how long it's going to take to get to here, because I don't have much. And if I play the video, you'll see that it doesn't go all the way through, right? So it stops right there whenever I get to the end. So even if I do that, I need to determine that speed. And in addition to that, I also know that my ball is traveling at a constant velocity too, so that helps as well. All right, so start at 0. Let's collect some data. I'm actually going to go into this toolbar and I'm going to click on this little stopwatch. This stopwatch is actually going to tell me the time. Now, I'm not even going to look at these other balls right here. We're just going to look at the first one. All righty. So what I'm going to do is I'm going to click play, or I'm going to click on this button right here, and I am going to calculate it. I'm going to collect data every single time it reaches 0.2 seconds. Now, once again, I'm going to start at 0 centimeters. Okay, so I wrote at 0, 0. Okay, so my time is going to increase by 0.2 seconds after every interval. Okay, so at 0.2, looking here, I could see that my ball is at a position of 5 centimeters. Okay, next up, I'm going to do a similar thing. I am going to do, instead of 0.2, I'm going to do 0.4 seconds. That goes by, making it, and then I'm going to determine where my ball's position is at 0.4. Okay, it moves and looks like it's at 10 centimeters. Okay, are you guys starting to see a little bit of a trend? All right, let's do 0.6. Okay, let's see where my white ball is going to be at 0.6. Okay, looks like it's at 15 centimeters. All right, and we're not going to guess what that last one is going to be, but we're going to kind of continue. In this case, we're going to continue doing this. And at 0.8, it looks like I'm at 20 centimeters. Okay, so in this case, it kind of already automatically did this for me, which is kind of nice. But the thing is, though, it's not increasing per second, right? So it's doing 5 centimeters. Okay, it looks like it's increasing by increments of 5 centimeters per 0.2 seconds. Okay, so my velocity is going to be increasing by a distance of 5 centimeters per 0.2 seconds. All right, now if you want to enter in your calculators, what is 5 divided by 0.2? By 0.2, it gives me 25. Okay, so it is going to travel 25 centimeters per second. 1 second. Okay? And so if we want, we could look down at this slope right here, according to our graph, and yes, sure enough, 25 centimeters per second. Boom, we got it. So we know the velocity, but now we want to determine how long it's going to take. Okay? Now, once again, We know the velocity and we know how far it needs to travel. So how can we determine how long it will take? Well, let's use unit conversion. Okay, so here I know I have 64 centimeters. Okay, and I want to use this nice little thing right here. If you remember back from unit conversion chapter, and I want to put 25 centimeters per 1 second. Okay. So if you want to do that, my centimeters cancels out and I'll just be left with seconds. Or if you would like, all you would also need to do is you can use a little bit of algebra to determine this as well. Okay, so first of all, let me calculate this. So if I have 64 divided by 25, I'm going to get 2.56 seconds. All right, and that is going to be how long it's going to take to travel 64 centimeters. Now, I can also use a little bit of algebra because I know, let's see, where's a little bit more space? Oh, here's good. Okay, I can use some algebra because I know velocity is equal to how far it needs to travel divided by time, right? I want to find time, so all I need to do is determine the velocity. In this case, if I multiply time to both sides, okay, I will get time times velocity is equal to my distance. I'm going to change this distance to x, okay? Because that's what we usually do for position. And then I have to divide both sides my velocity. Okay, so 1 over v, 1 over v. Okay, velocity cancels out. So then I'm just going to be left with my time is going to be equal to how far it traveled over my velocity. In this case, I know it traveled it needs to travel 64 centimeters. And I know it travels at a rate of 25 centimeters per second. Therefore, I should get the same thing as I got above, which is the 2.56 seconds. Either way works. I'm just giving you all the tools so that way you are able to understand what is happening here. All right, and so I know it travels 2.56 seconds. All right, so at that point, I'll actually write into here, white ball travels 2.56 seconds to finish line. Alrighty, so now let's see who is going to win that race. All right, so it's going to be your job to determine which ball is the blue ball or the white ball, blue ball, or red ball is going to finish the race first. But I hope you've learned something today, and thank you so much for watching. I'll see everybody tomorrow.